Hi everyone, this is Machine Learning for Cache Management UserGuide. In this video, I'm going to show how to use the Experiment Helper app. For this video, I'm going to assume that you already have the synthetic trace generator solution. If you need to see how to install it, you can watch the installation video. The first step is to come into the executable folder. We're going to use the shortcut which will open the application. You can see here the Experiment Helper. It has three simple options. First, let's read the help. Basically, I'm explaining here the two options that we have. Use the synthetic trace generator, which will be this right here, in order to create request sequences that are favorable to the selected algorithm. Complete the form to define parameters such as the size of the cache, the expert to study, or the number of pages requests. Let's create a trace. All these properties are going to be embedded to the actual file. Since a trace is basically just the page request numbers, we cannot put these properties on the file. So basically what we did was these properties are added to the actual file properties. It's just metadata. For example, for the description, I want to create a trace that's going to be LRU, favorable at the beginning, then LFU favorable, LRU again, and LFU again. So for the synthetic trace, we only have two experts. I know that one of them is going to be LRU, and the other one is LFU. You can see that I cannot select LRU and LRU because it will just don't make sense. We need one to be doing good and the other one to be doing bad at the same moment. So since LRU starts first, I'm going to say yes, the first expert starts first. It will be exactly the same combination I'm doing this. Let's unselect them. It will be exactly the same combination I'm doing LFU first and then LRU, and then non-checking this. So let's do this. And then the cache size, it means how big my cache is going to be. Basically, I'm going to keep it small for the purpose of running the experiment relatively faster for this demo. This is going to be my max request size. Basically means the biggest page that I'm going to have, what number will be. In this case, if I select 5 times the cache size, it will be 500. If I select 10 times, well, it will be 1000. Let's keep it small. The number of changes, well, I can see that I will need 4 changes for this behavior to happen. So let's make it 4. The noise level. This is actually a percent of the trace size. It basically means how many of the trace requests that I get will be just noise. Noise means that it's a random page selected from the working set. Let's keep it at 0 so we can see the LRU, LFU behavior a little bit better. So trace size, let's keep it small, still for the purpose of making this run faster. And we're going to call this one my first experiment demo. And let's run the experiment. The experiment concluded successfully. We can see that for LRU we have 12,487 hits, and for LFU we have 9,424. Okay, so the trace was created. We can see that the config properties change it to the ones that we run in the experiment. You can see the description, you can see the second expert, you can see the max requests needed, number of changes, and the first expert as well. And all this is basically because the input, we can reuse it at any time. On my first, which is this input, will get converted into these config properties, and we can see the output here, my first experiment. Sorry for the typo. And we can see about around 25. The reason that we have a little bit more is because actually filling the cache is not included on the cache behavior here. Okay. And if we want to continue using the app, we can also have the pollution counter. We can count pollution on this, but it will be easier to actually count pollution in a bigger file. We can use the ARC LFU 500 result. If I want to understand what is this configuration, I can come here to the input and I can read this. This basically means that the first expert was ARC, the second expert was LFU. This is the cache size, this is the number of changes that I have, which is a lot. This is the max requests page. And since the first expert didn't start, it means that LFU started. I have a little bit of noise, which you probably see as well on the graph, and I have 100,000 traces. That's why it's a little bit bigger than the one that we did. And if I want to count pollution, here we are. Oh, sorry about that. We will find that file. It will be basically in the output, and it's called ARC. And we just saw that the cache size for that file was 5,000, and we can run the experiment. Okay, it says pollution counter finished running successfully. Okay. Since pollution counter is basically a statistic of the actual trace and how the three different algorithms that we have they behave on that trace, we're going to see those results in the stats. Let me close here. And as you can see here, we have the results. All these four files belong to that pollution counter run. The txt files are actually the percentage, so we can run, we don't have to run the whole pollution count again, and we can get the graph. Let's see the graph. Basically, this will be percentage of pollution. We can see that LRU by definition will never get polluted, since pollution is basically pages that stay on cache for more than n being the size of the cache, and unique requests. An ARC in this case only got polluted at the beginning when the cache was getting filled, but after that it didn't get any pollution on it. This is basically very dependent of the results and the cache, but you will see that in actual, since this is really synthetic, you will see that in actual real life experiments, ARC does get pollution. And in this case, you will see that LFU, in the moments that we want LFU to do bad, it actually gets really polluted for the bad behavior to happen, and then it starts cleaning up the pages, and then it start getting polluted again. We can see that it did this about 5 times because it's a 10 different shifts. The ones that did good, it doesn't have pollution. Then the ones that did bad, it has pollution. So this is everything for the user guide. Of course, that a researcher can obtain different synthetic traces depending on the combination that he chooses. He could obtain 6 different combinations and also have different cache sizes, different trace layout, different noise levels. And since everything is random, even if the same combination is selected, the results will be totally different. And for the pollution counter, even if we are studying the same trace, depending on the cache size, we will obtain also different results. Any comments, questions, make sure to use the comment section below. Thank you for watching.